Good morning, Year 12. I hope you're all fit and well. Use this screencast to help you go through the activities which you're going to be studying today. If I'm available, I will check in with you to make sure you're all right, but I can't guarantee that. So hopefully this will be useful in talking you through what you're going to do in today's lesson. Now, what you'll notice is I have shared another lesson with you. This one's actually called, the reason I put two is because it's from the second part of the food and health, geography of food and health topic. I don't want to get confused with that, so I might change that later. But essentially, it's the second part of the food and health topic, and the first lesson on this is connected with energy and water footprints in food production. And what you'll see, if I just checked Emery's, you'll see that I've shared with you. I'll just check one more, just down here, and there you are. There you go. There, the lesson has been shared with you already. Okie dokie. So you've got your learning intention, recognize and understand complex relationships between people and the environment. And we have a rather wordy syllabus statement there. The merits of a systems approach, input, stores, transfers, outputs to compare energy efficiency and water footprints in food production and relative sustainability in different places. But although it sounds a mouthful, we've done systems diagrams before. We did them for the drainage basin system, if you remember, but you've also done them for industry and farming, and we have talked about this before. So remember, with a farming system, the inputs, what is required to make the farm run well, such as human inputs and physical inputs, which we did at IGCSE. And then things like with the actual farming system, it was more connected with processes. So, what helps the farm operate, and the outputs were things like maybe the crops or the animals and the profit. Okay, so we have done systems diagrams before. Now, fortunately, our success criteria breaks it down a little bit more, so it's easily digestible for you. So you have describe and interpret a systems diagram, identify the ways in which energy and water are used, inputs throughout the food production system. And then you're going to use an example of cornflakes to illustrate this. Maybe you've had cornflakes for your breakfast this morning. This one, you don't worry about this last one. This has been left in there, but we used to study the resources topic, all of the resources topic first, but we changed the structure of the way we do things. So we'll come to the idea, the concept of nexus linking food, energy, and water later. I've checked it. The Firefly link does work. So first thing you'll do is go on to the starter farming types. You can Google these if you wish. In fact, I recommend you would Google some of them, but we do have some help in the Firefly page. So if you go to, ignore that there, that's the Nexus concept. We'll come back to that later. But if you go to this PowerPoint here, there's lots of nice pictures of farms. And, even from the pictures, you can get a reminder of, what's a pastoral farm? Oh, that's connected with grazing animals. Arables connected with crops, etc. Okay, so just have a look at that. Do Google the definitions if you're unsure, but you should hopefully be able to work out most of these definitions from the pictures. And there's a nice picture of some pigs there. Okay, but we'll go over that when I return after the half-term break. If anything, if you're just unsure about. Okay, so let's go on to the next activity. So this is a farming system, and this one, to be honest, is rather complicated and sophisticated systems approach. But you've got three questions that you're going to answer related to that. So a bit of thinking involved here. But what you'll see is you've got your physical inputs, your cultural, your economic and behavioural, and then you've got the process, the decision making by the farmer, and then you've got the patterns of land use, how the land is used, and that these here and what happens on the farm in terms of the inputs, the processes that occur, how the land is used, results in outputs. In this case, we've got animals and crops. And the idea is that with the commercial farm, the farmer is intending to make money. So you've got three different scenarios here, depending on how profitable the farm is. And then we have some negative feedback and we have positive feedback. And I want you to think about what the difference is between those. Okay, so answer these questions underneath the questions. Answer each of these three relating to that diagram. Again, if you do need to Google anything, show that level of independence required. But we will go through this when I get back from the break. Okay, now this activity 2 here gets a little bit complicated, but it's actually not. You can work as a group of 4, you can work as a group of 2, you can work as a group of 3. I really, really don't mind actually. But so you just set up a chat between you. You've done this before. Someone take responsibility. Find out, decide who you're working with. Someone take responsibility for setting up a chat room, and then work together to do this. So what you've got there is farming types, various farming types here. Inputs into that farm, outputs, processes, input, impacts, and examples. Now, shifting cultivation has been done for you as a model to show you how to approach this and the level of detail required. So in your group of 3, 4, 2, whatever it is, you are going to do the rest of these: nomadic herding, intensive subsistence, etc. Okie dokie. Now, where are you going to get the information from that from? That's a good question, isn't it? Well, fortunately, if we go to there's the actual template, but I've put it into OneNote for you. Where are we? Yeah, if we go to this extract from a textbook, you've got information about each farm, so you can see nomadic herding. So if you're doing nomadic herding, you read that information. You've got an example of a northern Kenya nomadic herding farmers. You can see that. You understand what the term nomadic means. That means just moving around, and herding that's obviously connected with animals. So the pictures as well will give you an indication of that type of farming. There might be lots of new terminology here. So basically, you're going to use this information here. There we go. There's shifting cultivation, extensive subsistence agriculture, information, and then you've got a case study there from shifting cultivation in the Amazon basin. You might even remember a little bit about shifting cultivation when we did Amazonia at IGCSE, if you did IGCSE. But even if you didn't, it doesn't matter because all of the information is there. So the idea is that between you, you're sort of like, okay, so say one person, let's say, I don't know, say Max says, I'm going to do nomadic herding and I'm going to do whatever, let's say intensive subsistence farming, and then someone else in their group, say Matt says, okay, I'm going to do tropical commercial plantation and etc. And then what happens is once you have filled in the table each, you're basically going to talk to each other about the different types of farming. There's only 1, 2, 3, 4, 5, 6 to do. Talk to each other and make sure you've all got a table filled in of these different types of farming. One thing I really maybe should just go over is the difference, because you do need to understand. If I just go back to the difference between intensive and extensive farming, let's see where we got something here. So intensive, there can be 2 types of intensive. There can be labor intensive or capital intensive. And all it basically means is, so if you had labor intensive, it means that there's lots of workers per hectare, resulting in high outputs per hectare. So essentially, a hectare is about the size of a football pitch. It's 10,000 square meters. So all you're looking at there is, well, in every sort of like hectare, let's imagine every football pitch, if it's labor intensive, there's lots of workers being used to result in high outputs. Or it could be a capital intensive farm. That would mean that there's lots of capital input. It could be fertilizers, it could be machinery, it could be pesticides to result in high outputs. Whereas the extensive, and think about the word extend, covering a large area. Extensive is the opposite. It's low inputs of either capital or labor, resulting in low outputs per hectare. So as you can imagine, like, these farms tend to be large because if there's low inputs of either capital or labor per hectare, right, you need a large farm for the farmer to make money. So sheep farming is a classic example of that. So if you think about the size of a sheep farm, if you ever driven by an area, looked at a sheep farm, you'll see actually, hopefully those sheep are spread over quite a large area, which is good for the sheep and they're happy. And but the inputs are low per hectare, resulting in low outputs per hectare. Okay, so hopefully, it should sort of like help you with this particular activity of understanding the difference between intensive, labour intensive and capital intensive, or particularly here, intensive and extensive. And once you've done that, let's go back to here. So once you've done that, go on to activity 3, energy efficiency in food production. This gets a little bit more complicated here. But what I want you to do, you do have it, say you've got a PowerPoint in Firefly. Your idea is you're going to try and rank these kinds of farm systems from the most energy efficient to the least. So the first thing to do is to look at it and go, okay, well, which one is the most energy efficient, which one's the least energy efficient? And I want you to start to think about, well, what energy would be required to operate each of these types of farm. Now, if you go to the Firefly page, and it is activity 3A, I've called this one, you'll see a PowerPoint there, which I'd like you to look through and take some notes on energy efficiency ratios. It's probably a good idea, actually, to take some notes before you attempt that last activity, okay? You've also got a diagram there to help you interpret that. And I'm not sure you'll get much further than that. I would prefer, it would be nice if you can get onto it, and if not, finish this for home learning, please. If you could do activity 4, where you use the resources, it says below, that should be in the Firefly page, sorry, to complete the worksheet. Again, just double click and type in there or write. So complete that worksheet there about how is energy used at different stages of production. And then you've got activity 5, draw diagrams to show them, simple diagrams. We're looking at simple diagrams to show the energy used in different stages in the production of cornflakes, which many people eat for their brekkie in the morning. Okay, don't worry about water footprint. Let's just have a look. Is this going to be? I just need to remind myself how long this task is. Yeah, that shouldn't take you too long. That shouldn't take you too long. Do you know what? If you have time, by all means, go on to water footprint. But if not, don't worry about that. Just for home learning, just get up to completing activity 5, because I don't want to set you loads of work. You need a break over the half-term break as well. But of course, this lesson doesn't take place till Thursday after we get back. So what I would say is, get up to activity 5, simple diagrams for different stages of in production of cornflakes. Don't worry about that unless you do finish early, which I don't think you will. And that's it. And then for home learning, just ensure that you've finished up to activity 5. Okie dokie. So let's just go back to there, the lesson. And you've got some information, lots of information there to read and help you understand energy efficiency ratio. And that's the information there that you can use for the activity relating to cornflakes. Okie dokie. And that's about it. So I would like to wish you a absolutely fantastic half term. I'd like you to thank you for working so hard this term and being such an amazing group on CSL. It really has been a pleasure. And I know it's not the easiest of times, particularly with things like connectivity, with internet issues and things like that. But I think you've done really well and made a great start to the IB course. So I'd like to thank you. Have a fabulous half-term break, and I'll see you when we get back. Bye-bye.